Okay, binomial expansion. So you only need the first three terms. The first term is really simple, isn't it? The first term is going to be 2 to the power of 9. The second term is going to be 9 choose 1, which will just be 9, but you can check it in the calculator anyway in a moment, times 2 to the power 8, so that power drops 1 and we get 1 power of this side, minus x over 16, and that's multiplied by as well, so I'll put that in like that. Then I won't worry about that quite yet. Then I'm going to set up the next one. 9 choose 2, drop the power of 2 1, but then that power there increases to squared. So 2 to the power 9, we can chuck that into the calculator and just get 512. And then 9, right, so to get the 9 choose 1, you go maths. No, you don't. Ouch. You go option, statistics. What am I doing? What am I doing? Okay, let's start that again whenever we get confused. So go to 1, go to, we don't want maths, so we go option, then it's not statistics, it is probability. So probability being there, then it's NCR, so it's 9 choose 1, which is 9. And then we're going to multiply that by 2 to the power 8, and then we're going to multiply that by negative 1/16, negative 1 over 16, and that's giving me negative 144 x, and this is going to give me all of the x squareds here, so I know it's x squared at the end. I want 9 choose 2, which is 36, so that is 36 times 2 to the power 7, out of that, times, and then I want negative 1/16 squared, so I'll put that in there like that, and that's giving me 18. So what that means is that my final answer is 512 take 144x plus 18x squared. And it's good form to put another plus with a few dots going after it because it is a continuing on series. Right, now, given that the first two terms in ascending powers are 128 and 36x, for this we've got to find the value of that. So what this means is we already know what this expands to for the first few bits. If we were going to be multiplying them by a plus bx, well, let's just do that. I'm just going to put that in underneath there and put, right, I'm going to times that now by a and bx. I'd have 512a for my normal, just my basic constant with no x's involved, so I can sort that out for this. 512a is going to equal 128, therefore a will be 128 over 512, and I think that's a quarter, but let's not try and be too clever, and it is a quarter. So now that we know that, well, that's a nice thing to know, and we can put that in a moment, but just before we do, we now need to know how many normal x's we've got. We've got 512bx, and we've got negative 144ax. So what that means is, if I write that out, 512bx take 144ax is equaling 36x. I can take out the factor of x all the way because it's in everything, divide by it all, and I've got 512b take. Now I know that a quarter is a, so 144 times a quarter, let's just do that now, is 36, equals 36. So if I add 36 to both sides, I get 72, and then if I divide that by 512, I get that as a decimal, or 9/128. And that's that. Except it's not. I just realised I made a mistake, and I've been trying to be too clever. Just in my calculator here, I hit answer. I did 36 divided by 512. 72 divided by 512 is actually 9/64. I thought that seemed a bit strange, so it should be 9/64. That bit there is right. That was just me simplification. That is that.